What is the nature of consciousness? What are emotions? Why did consciousness emerge at all? What is the relationship between the physical and the mental world? How is everything connected? Ever since the first wanderings of our ancestors about the night sky, we want to understand humanity's place within the vastness of existence. During the 20th century, science replaced religion as the ultimate arbiter of truth. It laid down the principles of the technology that surrounds us. Yet, our advanced civilization still cannot answer the fundamental question: what is the place of consciousness in the cosmos? As scientists dig deeper into the mysteries of their field, they increasingly lose sight of the big picture. And narrow focus research gives rise to a mechanical view. When we believe that we are an accidental creation in an extremely fine-tuned universe, humanity's purpose only amounts to a bitter struggle against the powers of nature. When we feel like strangers in our world, we become vulnerable to mental problems and uncertainty. Consciousness science changes everything. It is a truly interdisciplinary field which needs physics, evolution, sociology, basically combining neuroscience, which is the study of the brain, with psychology, which is the study of the mind or behavior. Because life requires constant interaction with the environment for food and shelter, these very interactions embed the brain within the energy cycle of the physical world. Successful perception and response makes it necessary that we intuit the environment. Such operation is an organizational analog of the outside world. So what is that organization like? Let's start with particles. We know from string theory that particles live in compact dimensions, which insulates them from gravity. Here, particles are shown as individual clumps of energy. But this is really a mistaken representation, because independence from gravity permits the wave function's expansion in space, time. This simultaneous existence leads to quantum phenomena such as entanglement. Every change occurs by particle interaction. Here, I represented just one particle. It is connected to the spatial field, the only way interaction or change can occur. From Einstein's theory, we know that the field curvature is stable and particles change this curvature. So how does that happen? Quantum mechanics shows us that particles can only produce two possible energy states, called upspin and downspin. In an upspin particle, the energy direction occurs toward the particle, while in a downspin particle, the energy direction reverses away from the particle. These effects oppositely change the field curvature, and that causes these long-term changes. Einstein field equations show that these two particle changes really the essence of global evolution. And if we look at the two particles that would be entangled with each other, forming opposite energy changes and curvatures, we could see that globally nothing would change, only these localized differences would emerge. Indeed, this can be visualized with a cake. Cutting the cake any differently doesn't change its size. Entanglement creates uneven outcomes. Taking more cake would leave less for everybody else. In the universe, these differences create poles with antipodal structures. In black holes, spatial curvature becomes infinite, creating such pressure that the dimensionality drops. That would mean that there has to be another pole with an increasing dimensionality. And these are the four-dimensional white holes that are also proposed to exist based on Einstein's theory. Here I represented the cosmos as a white brim hat. The positive curvature top represents the black holes, which must be compensated by negative curvature regions somewhere else. These are the so-called white holes. They show opposite behavior. The black holes have such strong gravitational field that even light cannot escape them, while white holes have a negative curvature which repels even light from their vicinity. The latter quality would also make their discovery impossible with traditional investigations. There are two recent work that support the above hypothesis. The first one is Maldacana's work, the so-called anti-de-Sitter conformal field theory correspondence, a mouthful name, which proposes that there is a two-dimensional boundary of the universe, and there is a negative curvature center, so-called anti-de-Sitter space, The tires here indicate the curvature of space and the dimensional differences as well, as it goes toward the edge. Narrower and narrower and smaller distances are represented. The other hypothesis was proposed by Armeiri, the so-called firewall hypothesis, which states that black hole horizons are forbidding boundaries with nothing behind them. From the above discussion, we can imagine the universe as a balloon. Its black hole firewall represent a boundary, and its white holes represent four-dimensional vacuum that expands space, causing this accelerating expansion, which is held back by the immense field strength of the black holes. Recent work by Tully and his colleagues found a similar structure in our galactic neighborhood, in this Laniakea supercluster. In the center, cosmic void is pushing gravitational objects outward, and greatest gravitational regions form a spherical boundary around it. So another representation of the universe really emphasizes the dimensional difference between the black holes on the left and the white holes on the right, represented by a hypercube, and the three-dimensional regions between them. The even-dimensional poles of the universe are highly stable, and the three-dimensional regions are not. The even dimensionality means that there is no interaction and no change, but in the three-dimensional regions where we happen to live are characterized by constant interaction, constant change, and which leads to complexity, biological evolution, and the evolution of intellect. There is one more way to represent the differences of the poles, and here I show the black holes as the space disappears because it becomes two-dimensional, but we know that time is infinite. It stops in black holes. In contrast, white holes, space is born there, therefore time is zero, but from our perspective, four-dimensional space is infinite. So these differences push and pull on the three-dimensional regions, causing them in this dynamic state. If we look at our universe one more time, we can see that really it looks like and acts like an elementary particle. The physical laws are limited to within its boundaries. We cannot leave our universe because getting close to the black holes would destroy life and even matter. We cannot approach white holes either because they repel any incoming energy. The Schrödinger equation, which was written for particles, also applies for the universe. So we can conclude that the universe is an elementary particle. Our next question comes, how does the mind fit in this picture? Based on its size, its energy level, the mind is about halfway between the particles and the universe. And as I will show in the rest of the presentation, the intelligent mind recreates the fermionic organization in a biological system with its sensitivity to time. So let's see what that means. Because matter takes shape in space, the mind exists in time. And as you remember, we showed just one particle, and here I represent just one fermionic mind particle. They are orthogonal, which means that matter exists in space. It takes shape in space. The planets, stars exist in space. But the mind exists in time. We cannot point where the mind is, but we know in time that the mind exists from birth to death. What are fermions? These fundamental particles cannot be divided further. What is orthogonality? Moving forward in time contracts space, so space and time are orthogonal this way. The same relationship also exists between the spatial brain and the temporal mind. Because both gravity and acceleration lead to time dilation, both negative and positive emotions correlate with a slowing of time perception. Of course, their subjective experience is wildly differs, because stress is analog to gravity, and mental expansion, joy, is related to acceleration. I gathered 10 characteristics of the fermionic mind. 1. The first description of elementary particles was their indivisibility, unity, which also defines consciousness. The oneness of perception form a first-person unified consciousness. For example, the apple is a coherent representation arising from many brain regions, each holding a different aspect of the fruit, such as its color, shine, taste, connection to computers, even the Bible, Newton's gravity, and other experiences throughout life. Nevertheless, the immensely diffuse representation of the apple always remains a unified concept, underlying the uncompromising unity of mind. Particles cannot be divided into any other constituents. When particles are cut, they form lower energy versions of themselves. When the connection between the two hemispheres of the brain is disrupted, they form the two cortical hemispheres, form two separate perceptions, concepts, and even minds. Sometimes even they have conflict because of that. 2. Elementary particles are separate, indestructible, and therefore constant energy. No matter how many changes we impose on the electron, it remains an electron. Despite of massive changes occurring during the life of a person, he or she remains the same person. Although your current self may not have much in common with the child of your birth, the constancy of self is preserved from infancy to old age. 3. The brain's homeostatic regulation, based on the so-called resting state, is independent of consciousness. Homeostatic regulation generates changes that slow time perception, and these are experienced as motivation. The slowing of time perception shows a mysterious analogy to time dilation, the famous slowing of the clocks in general relativity. Therefore, emotions are spontaneous and involuntary. As the fundamental forces of motivation, they regulate our thoughts and behavior. Because photons make the electron faster or slower, emotions make you feel more or less energized. 4. When the hospital patient is in pain, he needs to hear that the pain will go away soon. Why? Because he doesn't know it. When you bump your elbow, you never think that, oh gee, it will be over soon. No, the pain's never-ending quality gives it real debilitating and devastating power. In fact, all emotions have a sense of infinity. Because the matter particle can expand in space without limit, the mental wave function, our mind's emotions, possess a sense of forever. 5. Cognitive processes show discreteness, context dependence, entanglement, which can be described by quantum mechanics. Elementary particles, such as the electron, are very stable. Our sense of foreverness makes it impossible to accept death. The constancy of self resembles the electron's permanence. 6. we cannot see or measure a field, such as the gravity field, but its stable curvature keeps planets and stars from disintegrating. Likewise, our social world is stable, and this occurs because the strength of our attachments make losses painful. Therefore, we hold on to relationships as gravity holds on to matter. We do not let go. Seven, life depends on constant sensory interaction. If nothing else, our bodily needs have to be satisfied. Like elementary fermions, our inner world is dynamic and constantly changes. There is no free lunch, even in the brain. The brain pays for sensory information to the environment by the added energy needed for the enhanced frequencies. 8. Social interactions create differences in power, which makes every society hierarchical. As gravity curvature and pressure increase toward the center of planets and stars, the powerless members of society experience psychological pressure, which makes their life more difficult. Number 9. The hypothesis holds up a mirror reflecting our similarities to the electron and also to the universe. Like the electron, we are explosive and fallible. But like the universe, we have limitless creative power. 10. What can we expect in the future? The quarks formed hadrons, which is the center of the atom, a highly coherent structure. Humanity is evolving toward the emotional hadron. Trust allows social closeness, leading to self-realization, satisfaction, and fulfillment for every member of such society. Can we work together to achieve such coherence? We are an eternal and natural part of existence. Recognizing the fundamental unity of all existence can repair the fractured state in the sciences and provides humanity a sense of belonging. Finally, we can answer reassuringly to the breathless wonder first proposed by the campfire of our ancestors tens of thousands of years ago. Understanding consciousness is like truly recognizing ourselves for the first time. We are the children of the cosmos, and our technological and mental growth is supported by an infinite creative power.